Good afternoon. I want to take you on a little journey. And the models we build don't have to be super huge, but they should answer questions. This presentation is for unlimited distribution. So we're going to talk about where I work, what the radome repair process is, the problem we had, what our solution was, or we thought it was, how we modeled it, used interactive between people to come up with a better answer. So at Warner Robins in Georgia, we repair the largest aircraft that the Air Force flies, the C-5, C-17, C-130, and F-15. So very unique type of items that we work on. So what was the aircraft radome is the nose cone that covers the radar system. And it's basically has to be invisible to radar waves or else your radar isn't going to work. So the way this works is very simple, straightforward. The supplier sends in the radome. We depack it. You'll see CMXG, that stands for Commodities Maintenance Group. And the 571st Squadron of that maintenance group does the work. After that, it needs to be depainted. It's done by the same group and the same squadron. The repair process is done by a different squadron, but same group. We then, after it's repaired, we have to paint it. That's done by the 571st, so it goes back to who depainted it. And then it needs to get tested. So when it goes up in the air, we make sure it works before it goes up in the air. And that's done by a completely different group, the Electronics Maintenance Group. So what we have is a situation where there's two different group levels dealing with this item and three different squadrons, plus we have to deal with the requirements of the supplier. Which what they were doing is the supplier was sending in these radomes in batches of 8 or 10. And the repair turnaround time agreement was to get these back in 60 days. Well, that only gives us 43 working days. Well, we weren't missing those dates. So, and there were overly long wait times in between each of these processes. So the finger pointing starts. And they're blaming everybody else for not getting that date. Okay, so a solution came up, and it was going to take over a month to implement, and it was going to cost us around $25,000 to implement. So we had some time, so I thought, oh, I'm not sure this is the right solution, so I've got time to model it before we start buying all this stuff. So it became a rather simple model. The supplier becomes our source. A source should go into a queue because it might not be able to go into the delay of the next bit of work. And then that has a queue after that. And then the depaint, a delay and a queue. Pretty simple so far. Same thing, a delay and a queue for the next step. A delay and a queue. And then as soon as testing is done, it can leave the model. So sometimes systems seem so simple that the solution you might come up with, it seems like, oh, that would be the solution. But with what my head was telling me, this isn't going to work, I couldn't communicate that to leadership and all the other stakeholders. So that's another reason we modeled it, because the thing we had is, in the last 3 blocks, we only had 5 carts. If you remember, I said there were 8 to 10 radomes that came in. So obviously 3 of them had to sit around, so let's buy more carts. So we had to do a resource part of the model for the last bit. Okay, so when we modeled the solution, What we had was, we said, we worked 6, we had 5, so we worked 6 carts, 7 carts, 8, 9. We went all the way up to 10. And we only saved 10 days on the overall, which was 150 days, down to 140. They're still not at 60 days. Then we looked at the repair function. Normally there's one guy that does it, and he's able to work on 2 of these at the same time, just because of the way the materials work. So we said, okay, well, what if we have 5 radomes that we can work on, and there's 5 carts, let's work all those. Well, that becomes a training issue for people. But we modeled that, and it still didn't help us out. So, let me go back one. What we did realize is that the first 2 or 3, you could hit that 60-day mark. But anything after that was well over 60 days time and system. So now what do we do? Okay, so we took the model, made it look nicer because we were going to present it. So we added the ability to change the parameters before and during the model run, so people could see things happen live. And then we got all the stakeholders together in a room and ran the model and ran different things that they came up with. Okay, I've got this idea. Is this going to work? And we'd prove those out. We actually did this several times because some of the stuff they came up with, we weren't able to actually model at that time, so we changed the model up a little bit, make it even more interactive. So this is what the output screen looks like. And basically, where it says radome at the top, a little bit on the right in the yellowish box, everything in that yellow needs the cart. And then at the bottom, we have a whip level chart. How much is in each queue or delay? And that was nice for the people to see. The big red ball just means the model is stopped, because I hate pausing a model and forgetting I paused it. And I'm like, why isn't anything changing? So we can inject different levels. See, it's set at 10 right now. The middle bar chart is a utilization for the delays, so we can see who's busiest, who's not busy. And then the last one is the time and system histogram. So how long were they in there? And you see I've run 5 units through the system at this point in time, and already we're probably well above there. But if you look there, it says minimum work days 35.8 right near that histogram. That's another mistake people make, is that's the first one through. And it's kind of a psychological thing that people do. Whatever their best performance is, that they kind of accept as their norm. Well, that wasn't anywhere near the case, because we were doing over 100 days worse than that when the last one went through. So getting all those people together, what happened is we came up with some new business rules. So the supplier, we could have asked them, hey, can you change the repair turnaround from 60 days to 160? You know, something over 150, you don't want to trap yourself in. And on the Air Force side, we were like, no, we don't want to go there. What can we do? So what we agreed on was that they'll just send in 3 at a time, because we know we could get 2 or 3 on time. So we still needed to do a little more work. So in the repair section, which is the part that takes the most amount of time, we told them that one mechanic currently repairs 2 radomes at the same time. That's okay. If there's a 3rd radome and there's a cart available for it, then send a mechanic from another area over to work on that. So we work on 3 at a time. And everybody's okay with that, because there was enough people that were trained. In the painting, what happened was we just changed their priority matrix, because this isn't the only product that goes through them. There's multiple radomes that we repair. And what had happened was we had a very high-level issue with another radome, and they took that of just focus on this, make sure you get these out, and any other priority went to 0, essentially. Hey, if we got time and we see it, we'll do it. So they weren't painting these in a timely fashion. So we redefined their priority matrix so that they can, the high priority over here and this particular radome I'm talking about could both be serviced in a timely manner. And then in the testing, the facility we have for testing, you can only test one radome at a time, because you're using radar waves, and if you have more than one, they interfere with each other. So what we said is, we already know you're pressured. We don't want to overpressure you too much. So we didn't say, when a radome shows up, this one, you have to do it right now. That's too much stress on the system. And they weren't going to agree to that. So what we said was, if you've got one already, you're good, just do it at the normal pace. But if a second one shows up, then the next one you test has to be one of those. And they were okay with that. So with those agreements and business rules in place, we now meet the target times for the customer. Everyone's happy, and we didn't have to spend that $25,000. So that's all I have. Any questions?
Thank you so much. Appreciate the talk. One of the things I was most intrigued by was the focus you appear to have on communicating insights from the model rather than just numbers. Could you talk a little bit about that collaborative stakeholder process? Because it sounded like there needed to be some work in building confidence in the model so that they trusted it. And, when they come, they're going to spend some time sitting with you. That means they have to trust the process enough to spend the time out of their day to do that.
Right, very good. So he asked about the process and how I got the stakeholders together to trust the model. So, and it's hard for modelers because you already know the model. What you got to do is you got to reserve at least 15 minutes in the meeting to explain what the model is doing, what it's showing them, run different scenarios, because there's always going to be somebody in the room who doesn't trust it. So take that time up front of not getting any work done, essentially. So not creating new business rules, but just trust the model. What is it doing? What do these charts mean? I'm an engineer. I understand the charts. But people who work these things day to day, their thought process is different. So I hope that helped answer your question. Any others? I don't see any. We good? Okay. Well, thank you, everybody.